problem was there. So transfer function is generally denoted by transfer function as TF. So transfer function is Laplace of output upon Laplace of input. See, C of S is always the output. C of S is always output and R of S is always input. And we have derived the formula as G of S upon in bracket 1 minus plus G of S into H of S. Okay, so this is the formula. So always keep it in mind whenever you are calculating transfer function. कुठलाही सर्किट दिलेला असेल, कुठलाही ब्लॉक दिलेला असेल, ज्यावेळेस तुम्हाला त्याचं ट्रान्सफर फंक्शन काढायचं असेल तर तुम्हाला सी ऑफ एस अपॉन आर ऑफ एस लॅप्लास ऑफ आउटपुट अपॉन लॅप्लास इनपुट इज इक्वल टू जी ऑफ एस अपॉन 1 मायनस प्लस आर ऑफ एस. So, in an electrical circuit, we know that generally resistor is there, capacitor is there, inductor is there. So, suppose one circuit is there, electrical circuit is there. If that electrical circuit is like this, suppose circuit is like this, resistor is there, capacitor is there, and if you have to calculate the transfer function, then obviously transfer function is nothing but Laplace of output upon Laplace of input. Like this. Okay, this is your circuit. You applied input voltage Vi of t. Because of this input voltage, the current I of t is flowing through the circuit. Okay, this is our circuit. Voltage Vi of t is applied. This bracket t stands for time domain. Bracket t stands for time domain. So Vi of t is applied as input. Then current I of t is flowing through the circuit. Okay, and then because of that, the voltage V of t is generated. So for this circuit, your transfer function will be your output upon input. Obviously, output upon input. Transfer function is Laplace of output upon Laplace of input. But here, what is output? So output is Laplace of V of t. So see, this is first example. So we'll see it in detail. Output is Laplace, L for Laplace, Laplace of output, and input is your Laplace of input. Okay. See, this is output is V of t, input is Vi of t. So this is the transfer function here in this case. So when we take Laplace of output, output becomes VO of S. Output becomes VO of S. And when we take Laplace of input, it becomes Vi of S. Vi of S. So transfer function of this electrical network will be V of S upon Vi of S. I hope it is clear. So if we apply input here, then For after applying KVL is Kirchhoff's law. You might have studied this Kirchhoff's law in EEC subject, that VI of t will be equal to R into I of t plus 1 upon C integration of I of t dt. You have seen this topic in your electrical engineering subject. Huh? After applying KVL here to the input side. So see, this is VI of t here as it is equal to R into I of t plus 1 upon C. As this is a capacitor, it becomes 1 upon C integration of I of t dt. So this is KVL. Huh? When you apply KVL at the input side. When you apply KVL at the output side, it becomes V of t is equal to 1 upon C. See, here in output only capacitance is there. Integration of I of t dt. V of t is equal to 1 upon C integration I of t dt. Okay. So you have got two equations, one equation for input, one equation for output. When you take Laplace of this equation, this equation number 1, what you will get? Vi of t becomes Vi of s, because here Vi of t is in time domain, it will go into Laplace domain. So it becomes Vi of s. So it becomes R as it is. I of t becomes I of s. See here, I is in small. It becomes capital. Okay. And 1 upon C again as it is. 1 upon C is as it is. This integration is there. So when you take Laplace of this integration, you will get 1 upon S into I of t becomes I of s. I of t becomes I of s. So this equation is turned here like this. Now we'll turn this equation into the Laplace. So it becomes Vi of s is equal to 1 upon C as it is. 1 upon C as it is. Integration becomes 1 upon S. 1 upon S, and I of t becomes I of s. So V of s is equal to 1 upon C as it is. Integration becomes 1 upon S, and I of t becomes I of s. So these two are the equations of Laplace of input and output. Okay. So again, this can be converted as V of s is equal to. So simplify this equation. What will get? 1 upon C and 1 upon S is there. So it becomes S into C. 1 upon S into C, I of S. Okay. Again, you can simplify it as I of S is equal to, see, this I of S is there, 1 upon SC goes to left hand side, so it becomes multiplying SC V of S. Okay, so I of S is become SC into V of S. So this same I of S can be replaced here in this equation. So this equation now becomes Vi of S. Vi of S is equal to R into, instead of I of S, you can put this, SC into V of S. SC into V of S plus this 1 upon C, 1 upon S. It becomes multiplied by each other. then 1 upon SC, again SC into V of S. So V of S is common. Here 1 upon SC and SC common, cancelled. So it becomes Vi of S is equal to SCR. Here this is multiplied, SCR into V of S plus V of S. Correct? V of S. So V of S is common. So it is turned it as V of S upon V of S is common. So V of S, it becomes as 1 upon 1 plus SCR. When you simplify this equation, you will get this. कारण की हा V of S common आहे, so it becomes SCR plus 1 आणि मग तो SCR plus 1 ह्या साइडला जाणार, तर ते येणार 1 upon 1 plus SCR. So what is your Laplace, what is your transfer function? Transfer function is V of S upon Vi of S, and by solving this by applying KVL at the input side and output side, you get V of S upon Vi of S is equal to 1 upon 1 plus SCR. So this is your final answer for this circuit. For this circuit, this is the Laplace transform. Is it clear? Is it clear? Is it clear?
Yes, sir.
Okay.